Next, let's try problem 25, a subtraction problem in base 7. And this time I wrote down the original problem right here as normal, but before we even started, I wrote out what these would be in base 10. I just put in this expanded notation for base 7 and got this result from the calculator and this and got this result. And I came over here and now I'm going to do my subtraction in base 10. I'm just switching things around a little. And so I think that the answer to this problem when it's written in base 10 is 1,336. There's no law that says you have to do part A first. But somewhere along the line, the idea is that you're supposed to do this problem in base 7. So let's try it. We can't do 3 take away 4 without getting negative numbers, and so we borrow 1 from here. And when we borrow 1 from here, it feels normal because we're taking 1 away from the 2 and writing 1, and then we're bringing that 1 over that we borrowed and we're putting it here. But now do not think this is 13 take away 4. That'll goof you up for sure. This is a 1, 3 in base 7, and you got to remind yourself, what is base 7? It has 1s on the far right, and then each one of these is worth 7. So what's a 1, 3 going to be when it's in base 7? A 1, 3 is a 7 plus 3 1s. A 7 plus 3 1s is 10. So this is a 10 in base 10. This is a 4 in base 10, and 10 take away 4 is 6. And it's okay to write a 6 in base 7. So that is sneaky. Now 1 take away 0 is 1. That's not sneaky at all. 2 take away 3 can't be done, so we're going to practice our borrowing again. We'll take 1 away from there and get 3. We'll put the 1 here. But now we have a 1, 2. Right there is a 1, 2. But that's not 12. That's 1, 7 plus 2 1s. That's 9. 9 take away 3 is 6. And we have 3 up here left over. Take away nothing is 3. And so I think the answer is 3616 in base 7. Then the question is, does that equal this in base 10? And so it is 3 times 7 to the third plus 2 times plus 6 times 7 to the second plus 1 times 7 to the first plus 6 times 7 to the 0, or 6 times 1, or just plain 6. And on the calculator, I'm pressing the buttons, and that does equal 1,336. And so I've done both methods, and they both agree, and that's a good thing. So let's take a look at problem 30, another subtraction problem. It's in base 16. Bases that are over base 10 always have some extra kinds of symbols for the numbers up to the base. And so 1 is 1, 2 is 2, 3 is 3, blah, 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 9 is 9. But then 10 is an A, 11 is a B, 12 is a C, 13D, 14E, 15F, and 16 would be a 1, 0 because it's base 16, so this 1 is worth 16, and this 0 is worth 0 1s. So a 16 plus 0 1s is 16. Just like the last problem, I've multiplied each of these guys out down here using the expanded form, used a calculator to find what they were in base 10, and wrote them up here in base 10. So if I wanted to, I could go ahead and do this subtraction, and I sort of want to. So I think it's going to be 1066. Now that doesn't seem right to me. Something is wrong. So I believe I pressed the wrong buttons on the calculator. Let me track this down and press the right buttons. Yeah, I just simply copied the 189. So this is 393. And this should be 393. And that subtraction should give me 862. So I've translated this. I've finished part B already. Now the question is, can I come over here and do the work in base 16? And that's a little bit challenging. So I can't do 9 take away from 7 without going negative. So I have to borrow 1 from E. E is 14. When I borrow 1, I get down to D, which is 13. So this, when I borrow 1, this is going to become a D, which is, of course, 13. And the one that I borrow, I put here, but that is not a 17. This is base 16, so these are 1s and these are 16s. So this 1, 7 that you see, everything you write here on part A, everything you put on your paper is a base 16 number. The things you're thinking in your head may be base 10 numbers. That's what makes this so challenging. A 16 plus 7 1s is 23. So this 1, 7 that you see right here, that is a 23. 23 take away 9 is 14, but you can't write a 14 down here because that's an E. Now you got D take away 8, but D is 13. 13 take away 8 is 5. 4 take away 1 is 3. Subtraction doesn't have to be hard, but it can be very hard. Now the question is 3 times 16 to the second plus 5 times 16 plus E, which is 14, times 16 to the 0. Does this equal 862? And let me check on the calculator briefly. It does check, and so this number equals this one in base 10, and we've done this subtraction problem 2 different ways, and they both check, and we get credit for both of them, and we're doing pretty well. So what about multiplication of 2 numbers in base 7? Well, like the previous problems, I've turned these 2 base 7 numbers into base 10 by writing them in expanded form, and now I'm going to come over here and multiply these. And we get 2080. Now the question is, can I multiply these? When I'm doing my work here, I may be thinking thoughts in base 10, but I'm writing stuff down in base 7, and so it's useful to be thinking base 7 is this many 7s plus this many 1s, because I don't usually need 49s when I'm doing the arithmetic. You can usually get away with just 2 digits, which is really nice. So for instance, I have 6 times 6, and I think of that as 36 in my own little mind, base 10 mind. But how do you write a 36? You can't put a 36 down here because that's a base 10 number. How do you get 36 here? Well, wouldn't it be 5 of these plus 1 of these? So 6 times 6 in base 7 is 5, 1, and that's a little bit frightening if you're thinking about things carefully. Now I have a 6 times a 1, which is 6, plus 5, which is 11. But I can't write down that 11. I've got to turn that 11 that I'm getting in my head into base 7. 11 is 1 of these and 4 of these. So I'm going to put a 4 down and carry the 1. 6 times 3 is 18, plus 1 is 19. But how do I do a 19 with 7s and 1s? Wouldn't it be 2 of these and 5 of these? So I have 2, 5, 4, 1. Now in the next row I move it over and I'm multiplying by a 1. So that's pretty easy because 1 times anything is itself. So 1 times 316 is just 316. Now I'm adding in base 7, so be careful. 1 is 1. Hallelujah. 4 plus 6 is 10. That's 1, 7, and 3 1s. 1 plus 5 plus 1 is 7. I can't write a 7 in base 7. So how do you write a 7 in base 7? Well, it's one of these and none of these. It's 1, 0. 1 plus 2 plus 3 is 6. So I think I'm getting a 6, 0, 3, 1 base 7. The question is, does that equal 2080 in base 10? Well, my calculator will do this calculation if I can manage to write it down. And when my calculator calculates this, it does actually get 2080. And so this checks, and we're done.